Since the beginning of time, humans have dreamed of flying, of soaring like birds. From the paintings of our ancestors to the myths of great civilizations, some of the most notable scholars in history devoted their lives to the dream of flight. Leonardo da Vinci, Henry Cavendish, Sir George Cayley, and Otto Lilienthal, among others, were the giants that dared to dream of taking our species into the air. And it wasn't until December 17, 1903, on a windy beach in North Carolina, that our collective dream took flight. It wouldn't be until 1927 that Charles Lindbergh showed us that the dream could transform the way we looked at transportation. With his transatlantic flight from New York to Paris, he sparked the beginning of commercial aviation. Over the last few years, we have witnessed the launch of that same dream in the field of electric vertical takeoff and landing vehicles. The year 2019 was the year it all came together. Our company, Kitty Hawk, named after that memorable place in aviation history, is one of them. Today, we'd like to share with you a comprehensive look at our Heaviside vehicle and why we are proud of the unmatched achievements that have been demonstrated across hundreds of flights.
I'm Michael Huerta, former administrator of the FAA and an advisor to Kitty Hawk. When I was administrator of the FAA, the industry came together with us to completely rewrite Part 23, the airworthiness standards for small aircraft. It was our intent to foster in a new wave of innovation and for companies to develop new concepts and new ideas while meeting our high standards for safety. Under Part 23, the agency doesn't tell companies how to build the airplane. Instead, it lays out the standards that need to be met for safety, and it leaves it to the companies to figure out how best to do that. Under the new Part 23, we've enabled exciting new aircraft like Heaviside.
We believe that Heaviside is the culmination of a collective dream almost 100 years old that is demonstrating the power of eVTOL today. Our vehicle is named after Oliver Heaviside, an English self-taught electrical engineer, mathematician, and physicist.
This is a single-seat aircraft, and it has 8 tilting variable pitch electric propellers. It has these 2 up on the canards here, and then it has 6 back on the main wing. What's so cool about these main wing propellers is that they are stuck behind the wing, and so when we take off and we start to transition, the air is pulled over the wing and down into the propellers, keeping the air attached. So even at very low transition speeds, the aircraft is extremely stable. There's very little turbulence or buffeting, and it's extremely efficient because the wing is working to its fullest extent, actually a little bit more than what was possible without the propellers. And the propellers are working to their maximum extent.
Heaviside has a range of up to 100 miles, speeds up to 180 miles per hour, and takes off and lands in a 30-foot by 30-foot area that does not need to be paved. It is exceedingly quiet at 35 dBA at 1,500 feet. By the end of 2019, Heaviside vehicles have performed over 237 successful transitions from hover to forward flight mode and back. Heaviside operates in 2 basic flight modes.
So with this aircraft, the first phase of flight is hover. It can take off vertically, and then you can push the stick forward and it will transition to a forward flight mode in which lift is provided by the wing and the propellers are just providing a little bit of thrust. The pylons being built into the back of the wing, it means that we can take that boundary layer that builds up on the wing and we can drag it out over that pylon. We can partially hide that pylon from additional drag. So it makes an incredibly efficient airframe in cruise.
This innovative approach reduces the energy requirement and the noise emissions in transitioning, 2 mission-critical aspects of our development criteria. There are 4 areas that we have focused on in building Heaviside. Each of these areas has been fully demonstrated. A huge part of our goal with Heaviside is to increase the safety of small aircraft. This is central to how we approach the design of the aircraft, as well as how the pilot interacts with it. In flight test, we are in a new era.
What we found is that actually, with the flight computer, we can make it respond even better than a human pilot could to failures. And that reduces pilot workload, and it makes it so that pilots are safer And the pilot just is decision maker. They don't have to do a bunch of stuff on top of that. They don't have to learn 20 different failure modes to handle. They are just a decision maker at the end. So because this aircraft has 8 propellers, you can lose any propeller and it still has the thrust to do hover takeoff and landing. Now let's say you lost both of these motors out here on the wing. It would still, because of the efficiency of how the wing and the propellers work together, it would still have the thrust to land at about 30 knots in a run-on landing. So not only do we handle like a single failure, we can handle multiple failures of systems and still have an aircraft that can safely get on the ground.
In parallel, our team has developed a custom ballistic recovery system that can operate through the vast majority of the envelope of the aircraft.
One thing you'll notice with this aircraft is this is actually an aircraft configured exactly how we flight test it. We just rolled it out of the hangar. There is no pilot in this aircraft, so the vast majority of our test hours can be done without a pilot. And this is tremendous improvement in safety in the field of aircraft development, because it means that we can push the envelope harder than we ever would with a pilot before that pilot steps near the aircraft. And we can try failures in flight that a traditional flight test program would never dream of, given the risk to human life. But we can do them, and then we can make sure they work. While there have been some demonstrations from our competitors that are really exciting and deserve attention, what we're very proud of here is that any number that we claim is from flight test. We have put a huge focus on demonstrated performance and demonstrated capabilities. And most of this performance came about and was really shown in 2019. Heaviside not only delivered on the performance that we thought we would see in design, but we did quite a bit better. We expected about a 75 or 80 mile useful range out of this vehicle, and we were a little conservative in our estimates of aerodynamic performance. And so when we got out to the test field and we were able to show how low our energy use was and demonstrate 100-mile flights while holding significant reserves, we were blown away. We didn't think that was going to be possible. Every bit of performance that we've claimed is demonstrated with batteries that are available today, with components that are available today, with real aircraft in the field like the one you see behind me.
This is a critical point to make in an industry that has had to answer hard questions around the limitations of lithium-ion batteries and energy density, as well as the feasibility of vehicle configurations. Efficiency in aviation, and especially in UAM, cannot and should not be measured just in terms of fuel burned. And not just because in our particular case, fuel burned is close to zero.
There are a few ways to get efficient aircraft. One is to spend a lot of time in optimization. And I think one of the really interesting things with the Heaviside story is that we actually didn't do that much of that. We put a huge focus on finding sources of drag and just designing them completely out of the equation. So what you see here is an aircraft that is not the result of endless optimization of complex models. You see an aircraft that's the result of good design and very careful attention paid to making systems simple and elegant.
We took our attention to efficiency even further, however, and aimed to minimize the electricity utilized on our plane, since overall energy efficiency is also an important goal.
What I am really proud of the Heaviside team for is the development of the Heaviside aircraft, which is a much more complicated beast with 8 separate power plants, and it gets a maximum lift to drag in the mid-teens. It is 1.5 to 2 times as efficient for its size as comparable light aircraft.
These design elements allow us to use less than half the energy per mile of travel than a Tesla Model S. And this assumes a vertical takeoff and landing and travel at more than twice highway speed limits.
So a lot of people think that it's not possible to achieve the ranges needed to have a useful electric aircraft. And I think what we've shown with Heaviside is that it really is. It just comes as part of the entire picture. You have to design the whole vehicle. You can't take an existing aircraft and just add batteries. You have to think about the aircraft as a system and optimize that system to get the best output. This aircraft, when it flies overhead at 1,500 feet, you'll hear about 35 decibels of noise. 35 decibels is actually so quiet that with just the breeze blowing through this valley behind me, we would not be able to measure the sound from the aircraft. So this aircraft is incredibly quiet. We take all of the torque that we used in hover and we put it immediately into making the aircraft as quiet as possible in cruise. It is actually almost as quiet as if it didn't have propellers at all. We can be flying patterns just over this valley that we're in, and aircraft landing at San Jose will actually corrupt our noise measurements. They'll be loud enough that we can't measure our own sound output anymore. At San Jose, it's 50 miles that way. It's 50 miles away.
The only noticeable noise is upon takeoff, which is still 65 dBA at a distance of 1,000 feet and becomes nearly undetectable in about 30 seconds.
So we're very proud that in 2019, the Heaviside team took this vehicle from concept to repeatedly demonstrated reality.
A type certificate for a new aircraft type ensures that the aircraft meets the airworthiness standards that are required by law. It ensures that the aircraft is safe not only for the people on board, but also for other aircraft and for uninvolved people on the ground. Obtaining a type certificate is a rigorous process. Under the new Part 23, it has enabled companies like Kitty Hawk to develop exciting new concepts and new ideas while meeting the FAA's very high standards for safety. And it's also enabled new aircraft like Heaviside, which demonstrate the success of that approach. It paints a picture of an exciting new chapter in aviation where we can see aircraft like Heaviside widely deployed.
My name is Sebastian Thwan. I started Kitty Hawk with Larry Page to build and conceive eVTOL vehicles for a new mode of transportation. Over the years at Kitty Hawk, we've built over 20 different eVTOL prototypes, and we've built over 120 individual aircrafts that we've flown to test this new concept. For us, 2019 will be remembered as the year in which the research and development finally came to fruition, demonstrating repetitive flights effectively, efficiently, and safely. There have been many great breakthroughs in aviation, from Da Vinci and Lilienthal all the way to the Wright brothers and Charles Lindbergh. And look, we are not among them. But for us, Heaviside in 2019 was a year that eVTOL became real, where we are able to demonstrate range and capability and safety of eVTOL. And if this concept catches on, I hope we get our little place in the history book of aviation.